Very good evening to all of you guys. Welcome to Byjus Exam Prep. So guys, today we will discuss, as well as we are starting a new subject basically, which is basically RCC. So today we will discuss about the fundamental concepts and the design for Flexure part. And from this particular portion, you may get a 1 as well as a 2-mark question in your GATE examination. That's why this topic is also important. So in this particular subject, basically what we will do guys, basically I have designed 3 to 4 lecture for the RCC part, so that we are able to cover all the important topics which is important as per the GATE examination. So in this particular session, we will discuss the question and at the same time I will explain the concept also. If you don't know about the concept, I will explain the concept part also. Okay. Pranam Krishna, how are you? Come fast guys and join the session. Okay, so that we can you can understand all the things and you will enjoy it also. Okay, so let's start the session guys. So those who are new over here, those who are watching this video as a first time, let me explain about myself also guys. My name is Krishna Yadav and I'm teaching from 9+ year, and generally these are my subjects which is I'm taking, which is basically environment, structure, RCC and mechanics portion. Okay. Now guys, there is one more information which I want to convey you. You can download our BYJU'S Exam Prep application, in which you will get the free GATE Achiever series, right? And there is one mega workshop for those who are giving the GATE 2024, right? So how to ace GATE 2024 in first attempt. You can join this particular session live on 9th of October at 12:30. Okay. So let's start with the question number 1 guys. This is the question number 1, and some questions are 1-mark question, but some question are 2-mark question also, right? So ready for both the type of question guys. You may find some question on MSQ also, right? But you have to solve all the question in this particular session, and let me know the answer also guys in the chat box. Okay, tell me the answer of first question which is in front of you, right? The partial sum are the fundamental concept which is based upon your codal provision, right? Which is also important for your 1-mark problem. Okay, so tell me the answer of this one guys. The partial factor of safety for concrete and steel are 1.5 and 1.5 respectively. Now the reason is what? Why it is so? Why they have mentioned the lesser factor of safety in case of steel and the higher factor of safety in case of concrete? Tell me guys, which particular answer is correct? Whether it is A, B, C or D? Sanjeet, B. Very nice. The control on the quality of concrete is not as good as that of steel. Why? Because we know that guys, the concrete is to be manufactured at the site, and if we talk about the steel, so steel bars are manufactured in the industry, which can be we can control the quality of that very easily, right, by technology, right? So that is the reason guys, due to which they have mentioned the more factor of safety in case of concrete, because it will depend upon the you can say that observation, as well as it will depend upon the person who is working at that particular site and how he trying to control the quality, right? It will depend upon the person to person. So that is the reason guys, they have mentioned the higher factor of safety for concrete. That's why B is the correct answer for the problem. Okay, so let's move to the next question in front of you guys. The flexure strength of M25 grade concrete as per IS 456-2000 in working stress method. Flexure strength. Tell me guys, the flexure strength, or you can say that modulus of rupture also. Modulus of rupture also. Krishna B, very nice. Tell me guys, the flexure strength of M25 grade of concrete is what? Do you remember the formula? Do you remember the formula, Krishna, Sanjeet? Modulus of rupture or permissible stress in case of bending tension, or it is also known as flexure strength of concrete. Okay, so tell me the answer guys, correct answer. Tell me the correct answer for the question. Modulus of rupture, or it is also known as flexure strength. It is also known as permissible bending tensile strength of concrete. Permissible bending tensile strength of concrete. One and the same thing, right? Now what is this value, guys? What is this value? Do you remember the formula? It is basically 0.7 under root of FCK. The formula is 0.7 under root of FCK, which is recommended by Indian Standard Code. Now you have to put the value of characteristic strength of concrete, which is basically 35 over here, right? So let's put 35 and tell me, guys, how much you are getting as an answer. It is C. Okay, Krishna, very nice. I will check it. 0.7 under root of 35. So we are getting a value of 4.14125 megapascal. Correct? So that's why, guys, A is the correct answer for the question. Sanjeet, very nice. A is the correct answer. A is the correct answer for the question. Next question, guys. Next question. Next question in front of you. Next question. The dimension of a rectangular section 250 cross 300. The clear cover is 25 mm and the tensile reinforcement which we have provided is 3 number of bar whose dia is 16. Now you need to tell me, guys, what should be the percentage of steel which you have provided in this particular case. What is the percentage of steel which you have provided? That is the question. 1 mark question. 1 mark question again. The percentage steel which you have provided in this particular problem. Tell me, guys, how much it is? Percentage steel. A, 0.45. Okay. Let's see, guys. The dimension is already mentioned over here. B is equal to how much? That is basically the width of the section. It is 250 mm. The overall depth which is given to us is 300 mm. This capital D is equal to how much? It is 300. Now our task is to find out the value of small d, that is effective depth. Okay. Now you can see here, guys, the clear cover, which is this one, it is given as 25 mm. Okay, sir. But I have to find the value of effective depth, which is the distance of this top fiber to the centroid of the reinforcement. D is equal to how much? So let's calculate the D value. D is equal to, can I say that, guys, it is 300 minus clear cover, which is 25 mm. Then we need to subtract the half of the dia of main reinforcement, which is equal to how much? It is equal to 16 by 2. Correct? 16 by 2. Let's calculate the value of small d first. Small d is coming around 267 mm. This value is 267 mm. Okay, sir. Now let's calculate, guys, what is the percentage of steel which we have provided in this particular case. It is AST divided by B into D multiplied by 100. Now how much AST we have provided? Can I write here, guys? It is 3 number of bar multiplied by area of each bar. Then divided by this dimension B into small d. The B value is already given, which is 250 mm. And the small d value is equal to how much? It is basically 267. Then multiply by 100. After this, you are able to get the percentage. Tell me, guys, how much it is? What is the value of percentage of steel which you are getting over here? Please tell me, guys. The percentage of steel which you get as an answer. It is coming around 0.9 something. 0.90%. So that's why C is the correct answer for the question. C is the correct answer for the question. Yes or no? C is the correct answer. Yes, very nice. Let's move to the next question, guys. And this is the provision, standard provision as per the IS code. The direct statement may come in the GATE examination also, guys, for 1 mark. This is 1 mark question, not a 2 mark question. Later on, we will have a 2 mark question also. Okay. Now tell me, for this particular problem, what should be the correct answer? The maximum area of tension reinforcement in the beam shall not exceed by which value? Hello, Santu, how are you? कैसे हो बच्चे? C, it is 4%. Very nice. 4%. Very nice. The maximum percentage of steel, PT max is 4%. It is 4%, right? But this 4% should be of overall cross-section area, not the effective area, right? 4% of B into D value. Very nice. Okay, next question, guys. Next question. So the answer of this question is C. Next question in front of you. Please read the question very carefully. It is very important. Okay. Read the question very carefully. The total compressive force at the time of failure of concrete beam section whose width is equal to B, but without considering the partial factor of safety of the material, is equal to how much? You don't have to consider the partial factor of safety. Now tell me, guys, what should be the factor which you have to multiply over here? We don't have to consider the partial factor of safety, but still we have to find what should be the value of total compressive force. .54. Very nice, Santu. 0.54. Very nice. What other student says? Do you remember, guys, in general, you have to draw this particular stress diagram so that you can calculate the total compressive force. And I think all of you have remembered this particular figure. And this particular value is 0.45 FCK, correct? Right? Okay. At the same time, we have a compressive force whose value is equal to how much? Whose value is equal to 0.36 in general. This value is in general when we are considering the partial factor of safety, which is 1.5. Okay. So 0.36 FCK B into XU. This is in general, correct? But tell me, guys, tell me, while calculating this particular value, which is permissible stress, maximum permissible stress in case of bending compression, which is 0.45 FCK, right? And this value, how we have calculated, it is nothing as 0.67 FCK divided by 1.5. Yes or no? Yes. Now tell me, guys, when you have this particular factor, then when you have this particular factor, which is 1.5, what should be the value of compressive force? Can I say that, guys, it is basically 0.36 something, correct? But let us consider when we are not considering this particular partial factor of safety. That means if I consider partial factor of safety as 1, very simple. Okay. So what should be the value of C dash? That is my question. What is the value of C dash? So what you have to do, just cross multiply it, you will get your answer. Just cross multiply it, or what you have to do basically, you need to multiply this value in this one, or you need to cross multiply this particular calculation. Tell me, guys. In this particular calculation, we have divided by 1.5. So I need to multiply it by 1.5. Then only I will get the answer, right? Very nice. So C dash is what? It is nothing as 0.36 multiplied by 1.5 FCK B into XU. Very simple. Now if you calculate it, you will get 0.54 FCK B into XU. So that means you need to put 0.54. You need to put 0.54. 0.54 aa raha hai na? Right. Yes. Next question, guys, in front of you. In LSM method, the design load is what? In LSM method, the design load is what? Again, 1 mark question, guys. 1 mark question. In LSM method, the design load is what? In limit state method, which particular load you will consider as a design load? Tell me, guys, quickly. D. Characteristic load multiplied by partial factor of safety for the load. Very nice. Do you remember, guys, in case of LSM method, it should be characteristic load. Whatever characteristic load is there, multiplied by partial factor of safety as per the LSM method. That should be your design load. That's why, guys, D is the correct answer for the problem. Very nice, Vinod, Sanjeet. Next question, what is basically characteristic load? Now, after this question, guys, we have 2 mark problem also. Okay. Tell me, guys, the answer of this question. What is characteristic load? What is characteristic load? B. Santu B. Sanjeet B. Very nice. Yes, definitely, guys. This load is nothing as it is the value of load which will have a probability of 95% not being exceeded during its design life of the structure, right? So you can say that, guys, only 5% are the chances by which your load may exceed during the design life, right? So in this case, the characteristic load is nothing as our option B. B is the correct answer. Very nice, Asif, Krishna, Wali, Sanjeet, Santu. Now, in case of under reinforced concrete beam, tell me, guys, the correct answer is what? In case of under reinforced concrete beam, both A and B. For under reinforced concrete beam, A is also correct, B is also correct. Very nice, C is the correct answer. Let's understand, guys, why it is so. So what is basically under reinforced? You know that, guys, if the actual depth of neutral axis is lesser than critical depth of neutral axis, then it is known as under reinforced. Or in case of LSM method, we are writing the actual depth of neutral axis is less than the limiting depth of neutral axis. So the first statement is what? Correct. Now what about second one? In this case, the moment of resistance is also less as compared to balance section. Yes, definitely. If you talk about the MR of under reinforced section, it is always less than the MR of balance section, right? And you know that, guys, if we calculate the MR value for over reinforced, it is greater than MR of balance in general, right? So A and B is the correct answer. That means C is the correct answer for the problem. Now the next question is 2 mark question, guys. Next question is 2 mark question. 2 mark question. You need to tell me what is the value of MR limiting. 2 mark question. Moment capacity of the section due to concrete as per limit state method. Now, guys, in this particular problem, they have not mentioned about the area of steel, right? So whatever value you have to calculate, it is nothing as MR limiting value only. Okay. Now tell me, guys, what is the value of MR limiting? What is the value of MR limiting? What is the value of MR limiting? Tell me, guys, quickly. You need to write some of the formula B. Okay, 73.781. Very nice, Santu. Very nice, very nice, very nice. Okay, so let's calculate it. It is very easy problem, I think so. You know that, guys, how to calculate MR limiting? It is nothing as it is QBD square. right? Now what is Q? Q is nothing as moment coefficient. And how we can write moment coefficient? It is 0.36 FCK K into J. Now the question is, what is the value of K, sir? K is nothing as, basically it is 0.48 when we are having FE 415 grade. Okay. If K is 0.48, then what is the value of J? It is 1 minus 0.42 K. If you put this particular value of K, you will get 0.8. Okay. Now let's put the value so that we can calculate the Q value easily. 0.36 FCK is equal to how much? It is 20. Then K value is 0.48 and J value is 0.8. Let's calculate how much we are getting as a Q. How much we are getting as a Q? So this is coming around 2 point. This is coming around 2.7648. Okay. Now let's calculate MR limiting value. MR limiting value. It is equal to 2.7648 multiplied by B. B is how much? It is 250. Then multiply by small d, which is 327 square, and multiply by 10 raised to power minus 6, so that it will be in kilonewton meter. So it is coming around 73.90 kilonewton meter. Now you can see, guys, only a single option is there which is very close to this, that is B, and that's why B is the correct answer for the question. Clear? Let's move to the next question, guys, which is basically MSQ. Be careful while giving the answer. This is the MSQ question, guys. MSQ question. MSQ question. Be careful while giving the answer for the problem. You need to find out which of the following options are correct or following statements are correct. And this question is related to your WSM method. Okay. So as per first statement, the modular ratio of Young's modulus of elasticity of steel to Young's modulus of elasticity of concrete. What is basically modular ratio? It is correct. First statement is correct. Correct. Very nice, Sanjeet. First statement is correct. We know that, guys, M is nothing as, it is ratio of ES by EC in general, right? First statement is correct. Now what about B option? What about B option? What is written over here? Kindly read it very carefully. Sigma CBC is 7, sigma ST is 230. The ratio of neutral axis from the compression fiber and the depth of balance section is 0.289, right? Now what it means actually, let me explain it first. You know that, guys, we can calculate the critical depth of neutral axis in case of WSM method. And how we can calculate it? It is nothing as, it is the product of K into D. Now you know that, guys, XC is nothing as, it is the depth of neutral axis, critical depth of neutral axis from the top fiber of concrete, right? From the top fiber of concrete, right? Okay. Now if you take the ratio of XC by D, then it is nothing as K. Now we need to calculate the value of K. How we can calculate it? K is nothing as MC divided by T plus MC. Now the question is, what is M, sir? It is modular ratio. Now how you can calculate the modular ratio? Let me show you that. How you can calculate the modular ratio? It is 280 by 3 sigma CBC. Now what is the value of sigma CBC? It is given in the question 7. Let's put it. So how much you are getting? How much you are getting as a modular ratio? It is coming around 13.33, correct? 13.33, okay. Now let's put 13.33 to calculate the value of K. So it is 13.33 sigma CBC, which is basically 7, divided by 13.33 multiplied by 7 plus 230. So this is coming around 0.2886. 0.2886. Understood? That means we can say that, guys, B option is also correct, right? Because it is 0.289. So it is also 0.289 approximately, right? So we can say that B option is also correct answer. B also correct. Okay. Now tell me, guys, if we talk about the C option, yes, definitely it is wrong, because if this one is correct, then this should be the wrong one. Why? Because the value they have mentioned is 0.361, which is wrong, right? Now last statement, D option. Sigma CBC is this, sigma ST is this, B is this, D is this. Now what is the value of MR? What is the value of MR? Moment of resistance for the balance section. MR for the balance section. MR for the balance section. So in this case, you need to write QBD square again. But guys, while calculating the value of Q in case of WSM method, what you have to write? You have to write half CJK. Now we know the value of K, but we have to calculate the J value, which is 1 minus K by 3. Okay. Kindly calculate the value of J first. How much you are getting? It is coming around 0.9038. Okay. What is the value of C? Which is basically 7 Newton per mm square. What is the value of K? It is 0.2886. Now kindly calculate the value of Q, guys. How much it is? This is coming around 0.91292. So let's calculate the value of MR balance. MR balance. B is given as 350 and D is given as 550. B is equal to 350 and D is equal to 550. Multiply by 10 raised to power minus 6. Let's calculate this value. How much you are getting, guys? It is coming around 96.66. Very nice. Very nice, Antu. 96.66 kilonewton meter. So yes, it can be also correct, right? D is also correct. D is also correct. Now you can understand, guys, in this way they can also put the question, right? First they will ask you some basic question of the singly reinforced beam. Then they will ask another question which is based upon your MR calculation. So in this way they can put the question also, right? So only 3 answers are the correct. A, B, C is wrong and D is correct, right? Next question in front of you, which is numerical answer type question, guys. Numerical answer type question. Tell me the correct answer for this. Numerical answer type. You need to calculate the lever arm value. Lever arm. What is the value of lever arm? What is the value of lever arm in the balance section? $253.09. Very nice, Santu. Any other student? Any other student who can tell me the answer? $253.09. You know that, guys, how to calculate the lever arm. lever arm is nothing as it is basically J into D. Now what is the value of J? It is 1 minus 0.42 K. Correct? Now what is the value of K? You know that guys, it will depend upon the FE415 grade. Now how much it is? It is 0.48. Clear? If you put this value, you will get the value of J, which is coming around 0.8. Okay. Now let's calculate the lever arm. Lever arm is nothing as 0.8 multiplied by small d. Small d is 317. Calculate it. 317 into 0.8. So we are getting a value of 253. 253.6 mm. And this is the correct answer. This is the correct answer. Okay. Next question, guys, in front of you. Kindly solve it and let me know the correct answer. So guys, which one is the correct answer? Tell me. B. Santu say B, sir. 69.39. 69.3945. Okay, very nice. Any other student who got the answer for the same question? Again, this is MCQ type question, guys. MCQ type question. Sanjeet B. Very nice. Very nice. Now guys, in this particular case, we need to find out the MR value again. That means MR limiting, right? MR limiting. So let's calculate how we can do it. MR limiting. It is nothing as it is QBD square. Correct? What is the value of Q? It is 0.36 FCK. FCK is 20. B is equal, K is equal to how much? You know that guys, for 415 it is 0.48 and J value is 0.8. So we can calculate the value of Q easily. It is coming around 2.7648. So let's calculate the MR limiting value. MR limiting is equal to how much? It is 2.7648 multiplied by B. B is equal to how much? It is 250. And then multiply by small d, which is 317 square, and multiply by 10 raised to the power minus 6, so that you will get the value of MR. So guys, we are getting a value of 69.457 kilonewton meter. That means B is the correct answer for the problem. B is the correct answer for the problem. Yes, very nice. Next question in front of you guys. Next question, you need to estimate how much area of steel which is required for the balance section. How much area of steel which is required for the balance section? That is the question. B. Krishna B. Okay. If you like the session, please hit the like button, guys. Okay. And share this session to other students also. Tell me the answer of this one, guys. We need to calculate the area of steel which is required for the balance section. A. Santu A. 757. 756. Yes, definitely, Krishna. Guys, the same problem is there. That means we know about the MR limiting value over here. That means you know the value 69.457 kilonewton meter is the MR limiting, right? For this limiting case, we need to estimate the area of steel which is required. So can I say that, guys, directly MR limiting is equal to how much? It can be written as T force, which is 0.87 Fy into AST, multiplied by lever arm, which is D minus 0.42 XU limiting. Correct? Now you know this particular value, which is 69 point, let cross check it. Yes, 69.457 multiplied by 10 raised to power 6, and it is equal to 0.87 Fy, which is 415 multiplied by AST. We don't know the value of AST over here. Okay. What about lever arm? You know that, guys, lever arm we can write it as J into D also. So what is the value of J? You know that it is 0.8. So J value, let write directly. J is equal to how much? 0.8. And D is equal to how much? It is 317. So kindly calculate the AST value which is required. That is also known as AST limiting. So guys, it is coming around 758 something, 758.57 mm square. So tell me, guys, can I say that A is the correct answer, which is very close to this answer? Yes, 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 very nice. Next question, which is again MCQ type question, but guys, it is little bit lengthy, but we are able to solve it, right? And this question is based upon doubly reinforced beam. Okay, doubly reinforced beam. This question is based upon doubly reinforced beam. Now guys, you may have 2-mark question further, right? All these questions are 2-mark questions. 2-mark questions. Kindly read the question very carefully, then only we will solve it. What is the problem which is written over here? Let's read first. The rectangular beam whose width is equal to 300, okay, having an overall depth of 400 mm. The concrete grade which we are using over here is M20 and grade of steel is 415. The tensile steel which is provided by 4 of 20 mm dia bar. In compression side, the steel is 2 bar of 12 mm dia. Now clear cover on both the side is 25 mm. Now this is the values which is given to us. That means the stress versus strain value is given in this particular statement also, guys. Now our task is to find out the stress in the steel at the compression level, but for the balance section, and that is the question. For the balance section, we need to find out the value of stress which is coming at the level of compression steel. So guys, for this we need to do further calculation. Let me show you that, guys, how we can do it. So let's draw some of the diagram first. One is your cross section of the beam. Then guys, stress diagram basically. Or what we can do, guys, leave this particular stress diagram, we'll draw the strain diagram directly. Okay, with the help of strain diagram we will try to find out the value of FSC. Okay, so I think you know that how many steel are there on the tension side. It is basically 4 bars. And how many bars we are having on the compression side? It is 2 bar only. 1, 2. What is the dimension? Dimension is 300 cross 400, which is overall. Okay. Now what is the strain value which is at this level? 0.0035. and the strain value at the tension steel is Fy divided by 1.15 ES plus 0.002. But our task is to find out the value of strain at this particular level, which is also known as ESC. Can we calculate it easily? Yes. You know that, guys, how to calculate axial limiting, because our task is to calculate the ESC value for the limiting condition only. So let's calculate axial limiting first. What is the value of axial limiting? If you know the axial limiting, we need to subtract the effective cover for the compression reinforcement. Then we are able to get this particular distance also, which is axial limiting minus DC. Clear? Clear? So let's calculate, guys, what is the value of DC first. DC is equal to what? You know that, guys, the clear cover is already given, which is 25 mm. And the dia of compression reinforcement is equal to how much? 12 mm. It is 2 bar of 12. And this one is 4 bar of 20. So it is 12 divided by 2. Okay, sir. Let's calculate this. So this is 31 mm. Okay. Now what is the value of axial limiting, guys? Axial limiting. What is the value of axial limiting? Can I say that it is K into D? So what is the value of K? It is 0.48. In this case, Fe415. Yes, 0.48. Multiply by small d. Small d is equal to how much? Let's calculate the small d value, guys. Small d is equal to overall depth, which is 400, minus this clear cover is 25, minus dia of tension reinforcement divided by 2, 20 divided by 2. So we are getting a value of 365 mm. Okay. So this value is 175.2 mm. Clear? This is axial limiting. Now, guys, after calculating axial limiting, we need to calculate the value of ESC. Let's do it. Can I say that, guys, when you have axial limiting, the value of strain is equal to 0.0035. Okay. But when we are having a value of axial limiting minus DC, then the value of strain is ESC. Just cross multiply it, you will get the answer for ESC, right? So ESC is equal to 0.0035 multiplied by axial limiting minus D. So axial limiting is 175.2 and DC is how much? 31. Divided by axial limiting value. Divided by axial limiting. So axial limiting is how much? 175. Axial limiting is 175.2. Please calculate this and let me know the answer of ESC. Then we'll calculate the stress also. How much you are getting? I think it is coming around 0.00288,070. Yes or no? Are you getting this value? Very nice, very nice. Now, guys, you need to use this particular table which is given over here. Now kindly check this particular thing. Our task is to find out the value of stress when the strain is 0.00288 something, right? Now we need to mark two values over here. First, you can see, guys, the first one is strain and the second one is stress. Okay. Now let's understand in which particular range our value will lie. You can see, guys, this is the value of strain and this is the value of strain. In between these two values, our stress will our strain value will lie in actual condition. Okay. That means, now listen, guys, you don't have to solve it. Just you need to understand what should be the answer. Now tell me, guys, don't interpolate it also, because this is a MCQ type question, right? Don't interpolate it also. You will get the answer directly. We know that, guys, when we have a strain value 0.00276, the stress is equal to how much? 351. Now our task is to find out the value of stress when we are having a strain value of 0.0028. Now tell me guys, definitely this value should lie in between 351 to 360, yes or no? This value should lie in between these two values only. You can see here guys. Between 360 and 351 this value will lie, yes or no? Yes, yes. So guys, we don't have to interpolate it also. We are able to solve it directly, right? Because we know that only a single option is there which is giving us as a correct answer. That's why C is the correct answer for the problem. Clear? Very nice. Very nice. Very nice. Very nice. Let's move to the next question, guys. Next question I'm giving as a homework. At least one question I will give you homework, guys. The question number 15 will be as a homework for you, right? This is a homework question for you guys. The last question which we are solving over here is question number 16, right? This question, at least you have to try it, guys. And please let me know the correct answer in the next session. Or what you can do, guys, you can put your answer in the comment box also. And let me know, let me tell you one more thing, guys. Tomorrow we have one more session at the same timing, which is basically 5 p.m., right? So in which I will discuss the design of shear part, slab bound, right? Slab, bond, torsion, like these type of topic, as well as shear portion, which is also important for your examination, right? So that particular topic I will take tomorrow at 5 p.m. Okay. Last question of the session, guys, which is MSQ. MSQ. In case of under reinforced section, tell me, guys, which of the following statement are correct? The actual depth of neutral axis is less than the critical depth of neutral axis. It is correct. The first statement is correct, yes or no? A is correct, very nice. What about statement number B? What about statement number B? The concrete reach ultimate stress prior to the steel reaching the ultimate stress. Now tell me, guys, in case of under reinforced section, whether steel will fail or concrete will fail. B is wrong, because we know that steel will fail first, not the concrete. So that what will happen, guys, your steel will reach to the ultimate stress prior to the concrete. Correct? Okay. What about C option? Moment of resistance is lesser as compared to balance section. Yes, definitely. That's why C is the correct answer. C is the correct answer. Now the question is, what is the value of lever arm? Lever arm of the resisting couple is less than that the balance section. Now let's understand what it is exactly. You know that, guys, in case of under reinforced section, we know that the value of XU is less than XU limiting. The value of XU is less than XU limiting. Okay. Now if I calculate the value of lever arm, so it is written as D minus 0.42 XU. Now tell me, guys, if I increase the value of XU, this particular parameter will increase. If this will increase, my lever arm will get decrease. Simple. Now tell me, guys, in case of under reinforced section, the lever arm will be greater as compared to lever arm for the limiting section. Yes or no? The lever arm for the under reinforced section should be higher as compared to lever arm for the limiting section. Right? That's why D is the wrong statement. D is the wrong statement. Clear? Tell me, guys, Arun, Santu, Sanjeet, Krishna, it is clear to all of you guys? So only A and C is the correct answer for the session, means for this particular question. Okay. Okay, guys, so I think all of you are able to understand all the question which we have discussed. Now only a single question which I am giving as a homework is question number 15, which you have to solve by yourself. At least try it. Okay, at least try it. Now guys, I am sharing a link over here, right, which you can join, and you will get the PDF of this session, guys, in that particular Telegram channel, as well as you will get the information regarding to the upcoming session also, guys. Okay, whatever upcoming sessions are there, you will get the information for that. So kindly join this particular Telegram link so that you can have the PDF of this session, guys. Okay, any doubt, any query if you have, guys, please let me know. And I hope all of you have enjoyed the today's session also. Thank you, Sanjeet. Thank you, Santu. Arun, thank you so much. I hope you have enjoyed it, right? So let's meet tomorrow, guys, at the same timing, 5 p.m. again, and in which we will discuss about the shear part. 5 p.m. tomorrow. Okay, guys. Okay. So let's close the session. Bye, guys. Take care. Thank you so much. I hope you have enjoyed it as well as you have understood some concepts over here, right? Thank you so much, guys.